For the functions f and g below, find f circle g and g circle f along with their domains. We'll do the functions parts first, and then we'll do the domains. So this is just a continuation of 2.2, where you're making new functions out of old functions. So we previously did adding, subtracting, multiplying, dividing, and now we're composing, putting one inside of the other. So if you notice, the process was the same. Find the functions, then talk about domain. So let's start. F circle g of x. By definition, this means f of g of x. So that is definition. What is g of x for our example? So this is f of x squared minus 4. That's substitution. So instead of g of x, we rewrote it. So if this was f of 7, you would say 1 over 7. f of 12, 1 over 12. We're giving it x squared minus 4, so you're going to say, the enthusiasm started off really high in the beginning there, and then it faded off. That's okay. 1 over x squared minus 4. Questions. So instead of this x, you replaced it with the function g. All right, let's go the other way around. G circle f of x. Now, if you get comfortable with these, I have no problem if you went from here to there, right to the end. I would prefer if you learned how to skip, only because these shouldn't be too bad. In fact, this whole section should be review. So by definition, this would be g of f of x. What is f of x? 1 over x. So instead of this x in the function g of x, we're going to put in 1 over x, just the 1 over x. The function g squares that and then subtracts 4. No, we're only putting in the 1 over x.
Yeah, 1 over x.
Okay, I thought you said. True. I know, but the thing is, this is what's going in. G is the one that squares it. You're only putting in the 1 over x.
Yeah, 1 over x.
Okay. You can stop. Yes. If you want to clean it up, you can. 1 over x quantity squared is 1 over x squared. But the previous step is fine. All right, questions on finding them. All right, let's talk domain. We'll first start with f circle g. So, as it says, where the domain is all values of the domain of g, such that g of x is in the domain of f. We're going to switch this around now. Where the domain is all values in the domain of the inside, such that whatever comes out of the inside is okay for the outside. Meaning that, let me draw a picture. When you have a composition, your variable x goes to this number called g of x under the function g. And then what happens is you take that number and you apply the function f, and now it goes to a new number, f of g of x. Thank you. So give me one sec. So what this domain information says is you have to have a number that's okay for g, such that when it comes out of g, it's okay for f. So we're always starting to modify, we're mainly modifying the inside functions domain and taking out anything that's bad for f, the outside function. So let's start with the inside functions domain. In this case, since it's f circle g, that'd be functions g. So let's look at the domain of g. G of x is x squared minus 4. Does it have any fractions? Does it have any radicals? even index. Does it have any logarithms? No, that's the third thing. I just told you a Y data answer. You're welcome. So what's the domain of G? All real numbers. So everything's okay for G, but F, what's bad for F? Yep. So what number would make a division by 0? Careful. Just look at F. You're one step ahead. 0. So whatever goes into F can't equal 0. So whatever goes into G is okay, but whatever comes out of G can't equal 0. Well, what do things look like when they come out of G? Close. Things that come out of G look like x squared minus 4. So that's what this says, input, output. So we have to make sure that x squared minus 4 doesn't equal 0. So if we set x squared minus 4 equal to 0, what do we get for x? Yeah, positive negative 2. So everything can go into G, but if 2 or negative 2 go into G, we're going to cause a division by 0. So what's the domain of F circle G? There you go. Now you might ask, why can't I just look at the final result and get the answer? I'll let you know. You can't look at the final result. You have to look at the individual functions themselves. Yes?
So if g(x) was a function on its own without having any f of x, g(x) could equal 0?
Yes. So if I just said, what's the domain of G, and you said all reals, great. But now that we have a composition involved, we have to worry about it.
So it can't be all real numbers if you can't use positive or negative because it will make it equal 0.
Right. But that's the overall domain of F circle G. So the domain of G itself is all real, but the domain of F circle G is everything but plus or minus 2. They're two different domains.
Yeah.
The thing is, you always start with the inside, and you take out numbers that are going to make something bad for the outside. So we started with all reals. We found that plus or minus 2 would be bad for the outside, so we had to take them out of all reals. Now let's talk about the domain of G circle F. We already did the grunt work, but we did it in reverse. The domain of the inside, in this case now it's F, would be everything but 0. The domain of G, as we saw, is any real number. So what this says is 0 can go into F. I'm sorry, 0 cannot go into F, but whatever comes out of F is okay for G. So what's the domain of G circle F? X cannot equal 0. So this one was nicer. So 0 can't go into F, but anything comes out of F is okay for G.